हेलो गाइस, हेलो। तो वेलकम टू स्टडी विद विवेक में। तो ये जो सेशन है अपना मेनली स्टार्ट कर रहा हूँ मैं अभी। जो आप अगर मेरी स्क्रीन देख पा रहे होगे तो लास्ट क्लास में है ना, अभी अपन ऐसे ही पढ़ेंगे, ठीक है। ऐसे इंटरेक्टिव सा थोड़ा लगेगा, पढ़ते रहेंगे जितना, क्योंकि अभी अपने पास टाइम नहीं है। टाइम इज टू कम, है ना। तो बेटर है कि पढ़ते रहें कंटिन्यूअसली, ठीक है। चलो, आपका टाइम ना मेरा टाइम खत्म कर खराब करते हुए पढ़ते हैं। तो स्क्रीन पे अगर आप देख रहे हो क्या, तो रजिस्टर, तो रजिस्टर क्या होता है? ठीक है, रजिस्टर अबाउट रजिस्टर्स, ठीक है। तो यहाँ से पढ़ते हैं हम। कर लेते हैं इसको एक बारी। व्यू कहाँ पे होता है? व्यू में नेक्स्ट फुल, ठीक है। So, small memories inside CPU to carry out a program execution. तो जो CPU रजिस्टर होता है, जो स्मॉल मेमोरी लगा नहीं, हाँ। इनको मैं गले में सही करेगा अगर आवाज आती रहे तो, ठीक है। तो ये वाला पेन रहा, इससे पढ़ेंगे, ठीक है। कलर चेंज कर लेते हैं, लो, ठीक है। ठीक है। तो स्मॉल मेमोरी, ठीक है, मेमोरी इनसाइड सीपीयू टू कैरी आउट प्रोग्राम एग्जीक्यूशन। स्मॉल मेमोरी इनसाइड सीपीयू टू कैरी आउट प्रोग्राम एग्जीक्यूशन। सीपीयू रजिस्टर। सीपीयू रजिस्टर मतलब ये जो भी बोलना चाह रहे हैं ना, जैसे ये मान लो अपना सीपीयू है, इसके अंदर एक छोटा सा पार्ट है वो रजिस्टर्स का, ठीक। उसके बाद आता है सीपीयू। सीपीयू, सीपीयू रजिस्टर्स। तो वन कंटेंट, वन रजिस्टर, वन इन वन रजिस्टर्स, ठीक है। एक कंटेंट एक रजिस्टर में स्टोर होगा, ना कि मल्टीपल रजिस्टर में, ठीक है, समझ आता है। साइज ऑफ द कंटेंट नॉट फिक्स्ड। जो साइज होगा कंटेंट का वो फिक्स नहीं, 2 बाइट हो सकता है, 3 बाइट हो सकता है, 4 बाइट हो सकता है, कितने भी बाइट का कंटेंट हो सकता है, बट स्टोर एक ही कंटेंट होगा इसमें, ना कि मल्टीपल, ठीक है। तो स्मॉल बी का मतलब होता है बिट, ठीक है। एम बी पी एस स्पीड आती है ना, यही बिट होती है वो, ये वाली नहीं होती, बाइट वाली, ठीक है, बिट वाली बिट होती है वो, ठीक। जो हमें पागल बनाती है ये नेटवर्क कंपनियां, तो जो यूज होती है वो ऐसे यूज होते हैं, तो ठीक है। कहीं पे जो सवाल ववाल लगाना हो ना, उस पे देखना, ठीक है। चलते हैं नेक्स्ट पे। नेक्स्ट पे, नेक्स्ट। तो समझ ही गए होगे, जो रजिस्टर्ड होता है ना, रजिस्टर, जो रजिस्टर होता है, रजिस्टर, जो ये रजिस्टर होता है वो एक सीपीयू का स्मॉलेस्ट पार्ट होता है, ठीक है। और सीपीयू के अंदर एग्जीक्यूट करते हैं, ये हेल्प करते हैं टू एग्जीक्यूट अ प्रोग्राम, ठीक है, इस प्रोग्राम को एग्जीक्यूशन करने में। और एक सीपीयू के अंदर, एक सीपीयू के अंदर एक ही कंटेंट होता है, ठीक है। कंटेंट का साइज कितना भी हो सकता है, जो अपनी पहली स्लाइड में हमने पढ़ा। तो सीपीयू रजिस्टर दो टाइप के होता है, सीपीयू रजिस्टर बता रखे टाइप, ठीक है, यहाँ टाइप, ठीक है। एक होता है जनरल पर्पस रजिस्टर, एक होता है स्पेशल पर्पस रजिस्टर। जनरल पर्पस मतलब जनरल यूज के लिए, नॉट फॉर दैट स्पेशल पर्पस के लिए नहीं यूज कर सकते हम। स्पेशल पर्पस रजिस्टर होते हैं, सब मल्टीपल रजिस्टर होते हैं स्पेशल पर्पस के, डिनोटेड बाई R1 R2 R3। जो ये जनरल पर्पस रजिस्टर्ड होते हैं उनको ऐसे डिनोट करते हैं, कैसे R1 R2 R3 करके, मेरे को तो समझ आ रहा है जो मैं रिवीजन कर रहा हूँ, ठीक है। तो ये चीज है। नेक्स्ट है सीपीयू रजिस्टर के जनरल पर्पस रजिस्टर्स। पढ़ने में दिक्कत है ना। किसी ने निशान मार दे मेरे राइटिंग पैड पे। ठीक। अच्छा। ओके। हेलो। ओके। ठीक है। चलो। तो जनरल पर्पस रजिस्टर्स में कोई का टाइप नहीं होता है इसमें, ठीक है। जनरल पर्पस रजिस्टर सिंपल्स होता है, ठीक है। उसके बाद आता है स्पेशल पर्पस रजिस्टर्स। स्पेशल पर्पस रजिस्टर्स में होता है, एक होता है एक्यूमुलेटर। पढ़ेंगे एक्यूमुलेटर क्या होता है, प्रोग्राम काउंटर क्या होता है, आईआर क्या होता है, स्टैक पॉइंटर क्या होता है, ठीक है। फ्लैश रजिस्टर्स, डब्ल्यू एस क्या होता है, प्रोग्राम स्टेट वर्ड्स, एड्रेस रजिस्टर्स, मेमोरी एड्रेस, ठीक है, एंड डेटा रजिस्टर्स। तो एक्यूमुलेटर क्या होता है, तो यूज टू स्टोर रिजल्ट, यूज टू accumulator, ये accumulator AC used to store, ठीक है, adds sometime one of the operand of ALU2, मतलब ALU2 बराबर used to store result of ALU arithmetic logical unit होता है ALU, and sometime one of the operand for ALU, ठीक है। तो मतलब इसका जो ये लाइन का कहने का मतलब है कि जो ईएलयू होता है ना उसमें दो इनपुट होते हैं, ठीक है। दो इनपुट्स होते हैं, एक इनपुट होता है एक ऑपरेंड्स होता है। क्या होता है, एक इनपुट्स एक ऑपरेंड्स। ऑपरेंड्स में बोल रहा है ऑपरेंड्स फॉर द ईएलयू। समटाइम एक ऑपरेंड हो सकता है ये। देखो, जैसे ईएलयू ये है, बनाइए, ये एक ईएलयू है, इसमें दो इनपुट हमें चाहिए। एक इनपुट होता है, दो इनपुट होते हैं हमेशा एलयू में, एक इनपुट दूसरे में ऑपरेंड होता है। और जब दो इनपुट होंगे तो एक आउटपुट निकले, ये जो आउटपुट सम टाइम के लिए स्टोर होता है ये एक्यूमुलेटर स्टोर करता है। इसके बाद ये आगे भेजता है, ठीक है। और कभी कभी क्या करता है ना एलयू, एलयू यही वापस से इनपुट दे देता है इसको, एक इनपुट, जो ये लाइन बोल रहे हैं ना ये सर, ये वाली लाइन। तो इसका यही मतलब कि कभी कभी ये एक्यूमुलेटर ही इसको इनपुट देता है, एक इनपुट ये दे सकता है एक्यूमुलेटर, किसको, एएलयू को, सॉरी एएलयू की। तो ये यूज होता है इसका, समझ गए। तो नेक्स्ट चीज है, नेक्स्ट अपन समझ लिया एक्यूमुलेटर क्या करता है। एक्यूमुलेटर क्या करता है, एक ऑपरेशन को वापस से स्टोर करा सकता है इसमें, ठीक है। उसके बाद नेक्स्ट, नेक्स्ट होता है टाइप ऑफ आर्किटेक्चर, किस टाइप का आर्किटेक्चर था। तो बेस्ड आर्किटेक्चर, based on ALU input, from where two inputs of a ALU can be taken। ALU क्या करता है, ALU बेस्ड आर्किटेक्चर क्या करता है, दो इनपुट ले सकता है जैसा कि हमने पढ़ा ही था। दो इनपुट ले सकता है वो ALU, ठीक है। ALU बेस्ड टू टेक AC बेस्ड आर्किटेक्चर, रजिस्टर बेस्ड आर्किटेक्चर, रजिस्टर मेमोरी बेस्ड आर्किटेक्चर, कॉम्प्लेक्स सिस्टम, और ये इतने बेस्ड के आर्किटेक्चर होते हैं, ठीक है। फॉर किसके लिए? एसी एक्यूमुलेटर के लिए, ठीक है, एएलयू। तो ये कौन सा बेस्ड होता? एक्यूमुलेटर बेस्ड आर्किटेक्चर था एसी, ठीक है। ये जो हमने अभी पढ़ा वो एक्यूमुलेटर बेस्ड आर्किटेक्चर था। आप पढ़ेंगे रजिस्टर बेस्ड आर्किटेक्चर। रजिस्टर बेस्ड आर्किटेक्चर कैसे होता है, ठीक है। रजिस्टर बेस्ड आर्किटेक्चर क्या होता है? एक्यूमुलेटर में रजिस्टर बेस्ड आर्किटेक्चर, ठीक है। दो इनपुट, इसमें क्या करते हैं ना, एक इनपुट जनरल पर्पस रजिस्टर से और मेमोरी से ले सकते हैं। उसमें क्या होता है, दोनों इनपुट्स हम जनरल पर्पस से नहीं ले सकते थे, और जो बेस्ड आर्किटेक्चर था, ठीक है, इसमें हम मेमोरी से भी ले सकते हैं और जनरल पर्पस से भी एक इनपुट ले सकते हैं, और एक इनपुट हम एक्यूमुलेटर से ले सकते हैं, ठीक है। We can take a one input from that accumulator, and one input from that GPR general purpose register or memory, we can take it. So this is the uh, AC based architecture. What is that AC based architecture? AC based architecture, ठीक है। AC based architecture, AC based architecture मतलब A1 plus A plus B, ये ले लिया हमने, we can take from A plus B, and R1. R1 is nothing but the registers. In above slide, I have to we seen like we seen that R1 is nothing but a general purpose register. So general purpose register we denoted using R1, R2, R3 like that. Okay. So remember that point. Some anywhere in that slide is R1, R2 is there. So you can assume that the R1 and R2 is the general purpose register. So uh, that AC based architecture here, we are able to see that one of that like R1 is that general purpose register we can take. Okay, one is input from that ALU we can take, like from that accumulator as well. The accumulator definition. Sometime the accumulator input is also we can take it, right? So ALU is that arithmetic logical unit, and it will store the some result into that, and then they will take the inputs and they will also get that input from the accumulator. Like this is the best architecture, like accumulator based architecture, right? Second is the register based architecture. This accumulator based architecture हो गया. Then it's done. Why? Because here we are using accumulator. That's why we are saying that this is the accumulator based architecture. Somewhere else we use registers, then we can say the register based architecture. That's it. Okay. So now let's see. Okay, here you can see as well that like accumulator is taking a, okay, then accumulator taking a plus b, then accumulator is taking a plus b, then we can store inside the AC accumulator, ठीक है, got it. Now next point is here we can see the register based architecture is this that this is point is saying like here we can take the output from the general purpose registers, all these 2 points. Here we cannot take, here in this architecture we cannot take the input from the memory, and as well as which one, second one is the we cannot take the memory from the like what is that, accumulator, and we cannot take the output from that general purpose registers, got it. So here we can take the two inputs from that grpc only, and accumulator give that sorry, ALU is nothing but the arithmetic logical unit. It will give the output as based on that these inputs, and he will use the output here, accumulator. Then accumulator in this architecture, accumulator is not giving that input to that ALU again. Okay, this is the way. So now here is the some example associated to me, like Satish to taught to me, like R1 is that general purpose register, and A plus B is the variable we can take it. Like here R3 is A, R2 is B, then accumulator will become R1 plus R2, then accumulator is output. Then again not compute the accumulator. Then accumulator go to the R4. R4. Okay. Then R4 plus R1 means accumulator. AB is the memory operand, right? AB is the memory operand, R1 is the general purpose register. I said to you, we know that the R1 is the general purpose registers. Got it? So now next slide. Go with the next slide. This is the revision is completed. Two accumulator based architecture we have seen, and second one is the we have seen the register based architecture as well. So now let's go with that next. What is the next one is the register is the memory based register, correct? Memory based register, memory based, correct? अब इसमें now in this architecture we can take the input from that as well as one input we can take from that GRP, GPR, general purpose resistors mean, and one of the output we can take GPR or like memory we can as well take. So this is the simple one. So here this is the memory. Okay, this is the R1, okay, it's taking the inputs to R2, and accumulator is R3, R2 plus B is become, okay, in R3, one input come from that general purpose, second input from that memory or like general purpose. Okay, it's okay, fine to us. Then next will become the accumulator goes down. Got it now. This is the some point is going on, guys. Okay, this is the input. Okay, here we can see R1 is the general purpose. Let's here we take general purpose register like R1 input, and here we are taking like a one input at a time. Okay, A plus B, two operand we can take it. So now here we can say A is the R2, got it? Then R2, it's take one input at a time. R2 is taken. Then again inputs is coming. R2 is coming. R2. Then again inputs is coming. R2 plus B. R2 is plus B. Then store into the accumulator. This output we can store inside the accumulator. Store inside the accumulator. Then accumulator data gives to the R3. Then R3 is make it. Okay. Then R3 plus R1 and store into the accumulator. These points is saying like that. Means A is storing into the R2, correct, inside the general purpose registers, and then R2 plus B means memory, then add and store inside the accumulator. Then this become both two variables come into the accumulator, then accumulator is stored into the register again. Then this is the process is happening, correct thing, guys? Okay. So now next is like here we store like that and perform the additions and store into the accumulator. Then accumulator give to the result some other person. Okay, some another chapter we will learn this thing also. Got it, guys? So now next is the complex. This is the little bit complex architecture. Sir, as told, okay, little bit complex, not more than that complex. But name is complex means this is definitely is complex. So now let's what is that meaning? Here we can take the inputs. Like its implementation is too difficult. Why? Because it is taking the input from the both things. It is taking the input from the both things. Like uh, it will taking the output complex. It will taking the output from that GPR also general purpose register and memory also. Not from the one input. It will taking the both two symbols. Here you can see the both two inputs, whichever you want you can take it in the above examples like register based architecture and a memory register based architecture and accumulator based architecture. Here we are taking only one input, only one input is the like memory or like general purpose register, and another is the some other inputs like operands. Okay, but in this example, they are taking the grpc or like memory inputs as well. So this is a little bit difficult. So implementation is a little bit difficult, but it's good to go. Yeah. So now let's go next. Let me explain. Let me think what is happening here. Then here he's taking A plus B plus R1. So here we are taking the input from the both sides. Then A plus B is stored into the accumulator. B memory come is stored into the accumulator. Then accumulator is stored to R2 because R1 is remaining. So R2 plus R1 then is stored into the accumulator, give the final outputs. Correct. Okay, guys. Okay. So now next thing is next output of use and symbols. Stack based architecture. What is that? Stack based architecture. So based architecture, it will take the inputs as he or she, you can see that it's no use, but we can see. Here we take the input from the stack, both the terminals, both two inputs. Got it? Out of use. Yeah, matlab, this is not. तो शायद हम stack based पे थे. Okay, stack based architecture. ठीक है. पेन कभी कभी गड़बड़ कर जाता है मेरा यार. Sometime my pen is failed. Okay, so don't worry about this. So now next is stack based architecture and okay, ये क्या हो रहा है क्या so now now our architecture is completed. Now next is the program counter. What is that program counter? Program counter क्या होता है? PC. First we completed the registers. Which register? Accumulator we completed. Okay, we completed accumulators. So accumulator we have four types. Four types we have. First one is accumulator based architecture. Accumulator based architecture. Okay, and second one is that register based architecture. Okay, third one is register or memory based architecture. Fourth one is the complex architecture, and the fifth one is the stack. There is no use stack based architecture. Both are important. Some देखो, मैंने क्या देखा है जब से मैंने पढ़ना स्टार्ट करा गेट के लिए कि आपको जो ये बेसिक पॉइंट्स पे ही क्वेश्चन आते हैं. क्वेश्चन इन सब बेसिक पॉइंट्स पे ही क्वेश्चन दे मेड some difficult level they will increase and make it that. Okay, so now let's go further. So it's four things. So program counters PC बोलते हैं. PC we can say that PC program counter होता क्या है? Storage address of a next instruction to the executed program. This will store the address of next execution. Suppose R3 is executed, Then program counter, what it will do, it will store the address of i4 inside the PC. Okay, this is the one of the register called PC program counter. So program counter is mainly is doing like storing the next instruction data, instruction address, or like something, instruction address to the next execution. Suppose 3 is executing, as the example is here. The 3 is executing and storing inside that fourth instruction address inside the program counter. This is that meaning wise. So now let's go with that next scenario. So this is the example here about the program counter. It's totally simple right now. Okay, next is the instruction registers. The store the current instruction of the executed. This is not storing. This is means here I would say the storing that the current instruction to be executed. Suppose in that memory I3 is executing, and inside the CPU IR register is there. Got it? IR is there. So this will storing the data here. Okay. CPU, how CPU know that which is the currently executing, which state is currently executing. CPU know that na IR, like instruction register. They can check inside this which instruction is executing. Suppose in that CPU, how to know next instruction? Next instruction, it will check inside the PC program counter, which address is there. In that address inside the memory, the CPU go and execute like that. This is happening, guys. Got it? Next is stack pointer. What is that stack pointer? Stop. Store the address of the top of the stack. Means stack means होता pop and pop out करके something. So top पे store करता है storage. It will store the top of the stack. Not important. But next come into that picture. What is that? Flag or status registers. Flags and status registers. Flags and status registers. So the program status words, it's saying store the status of the ALU result used to implement the conditions. What is the meaning of these lines? Means used to implement the conditions. Means inside the CPU, this register used to if and else condition. If you want to run this, if yes, then run this, otherwise run this, like that. For this, use these registers like flag or status. Flag means simply if flag is true, then make it 1. If it's false, then make it 0. It means flag or status registers, we can say. Program status words, we can also say that. The store the status of the ALU result, which is storing the ALU result, not accumulator result. ALU result, some means arithmetic logical unit is there. Okay, some result it will generating. Okay, that result is storing inside the state registers. Okay, sign from that yes, T positive or negative. Z means it's zero flag होता है. What is say? Sign factor flag. Positive. Yes means होता है sign factor flag. Sign flag. Z means it's a zero flag. Zero or non-zero. Got it. पॉजिटिव हो सकता है, पॉजिटिव और नेगेटिव. एक होता है एड्रेस रजिस्टर और एमआर रजिस्टर यूज टू सेंड एड्रेस टू द मेमोरी. what how the address is sending to the memory by using MR, address registers. I want to send this address to that memory. So we use this MR registers or like registers, correct? Now data registers used to send data to the memory. This register is using chain data to the registers or memory and used to send data to the memory and receive the data from the memory as well. Both the direction is like unidirectional data register is there inside the CPU or like memory. Okay, and then this is the memory and this is the CPU. Then go and give the data to the memory and take the data from the memory. This will happen by using the data registers. Got it. So now this is the example. Uh, some starting point revision we have seen. The address is, but this is the data versus is there. So the address versus the unidirectional. Okay, but data versus is bidirectional. Got it. The point is. So we have learned what is that thing? CPU registers, types of architecture, program counter, instruction register, stack pointers. Type of registers. Let's see. I am writing just simple things here. Okay. Okay. Here. Here we can type of architecture. CPU registers. So then two types of register. General purpose register, right? And one is the special purpose register. Okay, inside the special purpose register, we have the accumulator. Okay, and the program counter, some more registers are there. But in the accumulator, we have the type of architectures, accumulator based architecture. Okay, and register based architecture, right? And memory based register architecture. And next one is that complex. Last one is stack based architecture, correct? And program counters. What is that program counter will do? Program counter, program counter. What they will do? Program counter PC. It will storing the instruction of the next execution instruction. It will store the address of next execution instruction. Next, it will storing the address of the next instruction. Okay. What what is the next instruction? Suppose I3, then I3 it will store in the PC, right? And this will happen. And instruction register is it will be storing the current execution state, right? And a stack pointer is something. Stack pointer, yeah, stack pointer is to top. Okay, let's see. I'm just confirming program counter in next instructions will be storing and instead of the current storing is storing. Okay, stack pointer is there just over the top of the stack and flag of the zero and not zero कर देते हैं इसको. So the result status of the ALU result, status of the ALU result. Okay, status register is there and address register something. Thank you guys. Okay, now here we can see that here we are able to see accumulator first one and program counter as we know that and instruction register I know that stack pointer I know that and flag registers I know. Correct. Data register and memory data registers also. It's nothing but a MR is nothing but a buffers. Okay. Accumulator, we know that. Okay. Accumulator, we know that storing the data, storing the result of that ALU. ALU gives result to the accumulator, correct? And program counter is nothing but storing the next instruction to the program, correct executions. And instruction register IR, it is storing the current instruction to that uh, execution program. Stack pointer is the storing the address to the top of the stack. Okay, flag register. It will the flag register is nothing. It will storing the state result of the ALU inside that register stack. Nothing but other like registers, and address register AMR memory address register is there, and it will like the transferring the data kind of thing, something like that, correct things. And next is the data register AMR. So this is the revision of which time I'm saying that 11 session 2 completed. Okay, some other I will definitely do that. तब तक के लिए bye, good night guys. The one thing I want to share with you guys, some video I am uploading for my farming, and I am doing some, why, because I'm some anxiety, feel some anxiety while I'm preparing, by because continuously working and study and so that's why I start that thing. I will upload the continuously video on that, like short video and like long video. Definitely we will talk also, but right now not. Right now not possible. Just I am preparing now onwards. I'm going to start preparing that. Nothing but what is that meaning? Cow. Uh, Computer organization architecture. It will take 12 days to complete this subject. So every day I'm taking 3 to 5 sessions, 3 days a session at least. Okay. Meanwhile, I'm also working with my organization. Oh, thank you, guys. Thank you. Good night. Take care.